So who would like to kick us off this week?
I got short because I was on vacation there. Yeah, yes, kind of still fighting with the solver there. There's lots of packages that you can download that are pre-built and whatnot, but they all seem to not have everything that I want. Some are built with the Scotch packages, some are built with Métis package. And yeah, and ideally when you read documentation, they're like, well, if you want full scalability, you got to use both. You need like a certain scale package. Yeah, so I'm just trying to optimize it as I'm building it because it's actually not hard to build. You just have to put all the pieces together and then compile. So I'm just trying to find the best one for like the purposes of our computers, like 150 cores, how we can actually use all that. So yeah, I'm stuck testing mostly that right now. And then I'm actually playing around with Xarray again with the fields for the MT stuff. I just got it so that I'm going to try out storing the fields to using Dask and then just access them when needed. I don't know if we're really going to get any speed up, but I thought I'd try it because I like Xarray. I'd like to try and get it a little bit more used, but yeah, just got to find where it'll perfectly fit.
That's really cool. I'd be super keen to take a look at what you're up to there. Yeah. Are you working on like a simulation MT branch?
Yeah, that'll be my branch. I haven't pushed any of that recent stuff yet, but I'll be sure to do that here after this meeting.
That's exciting.
Yeah, I'm kind of emulating kind of what you've done with the field class as is, just because you can have the tags and stuff with Xarray. But yeah, that's why I was wondering if that's really, now that I'm getting into it, it's like, is it purposeful? Because we already have the fields project or the fields class, and it really does all that already. So yeah, I don't know. Xarray might be more purposeful somewhere else.
So with the fields, like I think it does deserve a re-look or a look over just because the access for them is generally pretty slow right now if you're not accessing all of them at once, grabbing like everything at once from a specific source. Otherwise, it's like it's actually pretty slow. So like, it's not useless going through and doing it.
And also storing fields, it's actually extremely expensive in terms of memory. Yeah. So I think
especially for like time stepping problems.
Right, even MT, I think if you're handling like relatively large mesh, so if you could do a lazy loading stuff like with Xarray support, I guess that'll be quite nice.
Yeah, okay, yeah. So yeah, it's worth testing for sure. Yeah, nice. Didn't think of that. Yeah, other than that, yeah, was on holidays.
Thanks, John. Dieter.
Yes. Yeah, I'm in the same, trying to get stuff that we tried in the last months to master, and documenting and testing is a slow process. But it's mostly rewarding because you find all the little bugs because you implemented something quickly, and then you want to do it nicely and you think, why did I do that? So yeah, it's a nice job. But yeah, nothing new there. It's all about the gradient and doing it solving it from many sources, many frequencies, many receivers, the adjoint state stuff, and data weighting. So yeah. Also, it's quite new for me that it's not yet inversion, but it's going to the inversion side. And like the first year or two of this 3D project, I was mostly involved with the solver. So really on a much more, let's say, fundamental basis, how to generate the field. So now the inversion is kind of, it's also a solver issue, but it's a completely different story. Yeah. Everything I printed before to check is now hidden because you don't want to see it every time you compute the field, how it was actually computed. All I did before, it's just hidden away now. That's kind of frustrating.
Yeah. What are you using actually for logging and such? Like, are you just using print statements right now, or do you have something more sophisticated in place?
Two things. So the solver, what I did first, multigrid solver itself is just, yeah, it has a verbosity parameter and it prints it. and that's now hidden away. But then the stuff I do for the command line is just with the logging, the inbuilt logging package. And then I print it to a file and I print it to screen, and you can choose these. Yeah.
Cool.
Yeah. And also the X-array, because you mentioned it. At the moment, it just makes me easy because if once you have a data set, then it's easy to just slap another data array on it. So if you have one data set, you just slap as many on as it, and each data set knows then which source, which receiver, which frequencies is. So you don't have to take care of that. So in this, I didn't find yet other quite usage other than a very easy way to store and access data. But yeah, for that, it's really handy. Also, if I suddenly want to have like the fields at the response at every step, then you just add to this data set a new data array for each step, which is kind of easy. Yeah.
I wonder if that's actually something we should look into for the data object as well.
I mean, the data object, you could already access it by like source and receiver, right?
Yeah.
Yeah. What I wasn't sure, like, it's if you got very uniform data set, it's kind of making sense, like using like something like an X-array. But sometimes data, it's not uniform. Like it's hard to put it in just a single table.
Yes.
So it has a little bit more complicated structure in general for the problem that we're dealing with. So
Yes.
yeah, I wasn't sure. I thought like a fields object is a little bit more sort of aligned.
Yeah. Yeah, that is certainly a point that, in my case, if I look at marine CSM, then I can easily put it in a grid because I just have a fixed amount of nodes on the seafloor, and all of them measure at each source position at each frequency. I think for an airborne EM, you can also do it easily, right? Because it's always the same source and frequency. But
yeah, but like even that for that case, like you don't have necessarily in the reality, like your receiver will have some missing point in certain frequency. So even though you got relatively uniform setup, but things can go fairly complicated.
But this you can just have an and that's not a big issue.
That's true.
In X-array, if it's just a few. But then, like for the IP or DC you do, where you have some sources with only one receiver or vice versa, then you get a lot of nonce, then it might not be that cool anymore. If it's just a few off data, then it shouldn't matter too much. Yeah. So yeah, I do think in SimPEG it's much more difficult because you are so flexible with your survey layout and methodology and all that stuff. So it would require a lot of thinking, I think.
Thanks, Dieter. Shelly, do you have any updates?
Nothing particular. It's a bit busy. I think I'm going to be busy until end of July. So yeah, I'm most working on geostatistics, although it's actually kind of fun. I'm mostly using the program called SGEMS. I'm not sure you guys have heard about that. It's actually open source code. It's been a while. And I think nobody actually cares at this point because the guy who developed it made a company. So he's not really maintaining this product, which has developed like 5 to 10 years ago. But still, it's actually pretty good shape. And it is structured like you can generate some sort of XML file. Then you can generate a script that you can run a bunch of geostatistical algorithm. So yeah, technically you can use Jupyter Notebook to generate that XML file and run a bunch of geostatistical algorithm and get back the result back to Python. So I mean, it's an interesting and yeah, so what I'm mostly working on is like a kind of combining that geophysics into geostatistics. So that's what kind of seems like people would do. So they use the output of geophysics and then feed into their geostatistical algorithm to get much higher resolution picture rather than a smooth image that we provide. So Yeah, it's an interesting process because you need to know what is the history of geology, like how it's actually sediments deposited, which direction they went. So once you actually recognize what is the kind of characteristics of the channels and lenses, then you can generate an image of what you think, and that you can just build the probability of those like correlation structure, and you can inject the geophysical data as well as using that geological patterns to generate much higher resolution images. It seems kind of fun, but nothing really related to SimPEG. But one good news is like a probably interesting point is if you can have a simple geostatistical algorithm that we can generate those fine resolution image and use like a SimPEG, like a kind of or geophysical simulation to generate the geophysical response. And that might be a good sort of pathway, I thought, that could help. But other than that, I don't have an update.
That's super cool, Sagi. If you do a presentation or something like that in the near future, I think, well, I would certainly be interested in seeing that. So
Yeah, I could do that.
This guy who made the company, so he built it around that tool, but then closed sourced it, or is it something completely different he does now?
It is still open sourced. I think I think it's a GNU license. I think so. It's a little bit different than our license, but I think it's still open source. So you can basically download and do whatever.
But you said it's not that maintained. I mean, if he forked it for his company and built a company around it, or if he does something completely different now.
I think he's like he has much more updated version, but the older version is open sourced.
Yeah.
Cool. Thanks, Sagi. Joe, do you have any updates?
Yeah, sure. So I've been I got a bunch of those pull requests on into SimPEG, all those little bug fixes that people brought up. Got a few new contributors on there, which is kind of nice. You know, every small bit little helps, so it's always good. I figured out why the doc tests were failing, because essentially what happened was the files that we had used to that we uploaded to our bucket, Google Bucket, whatever, were protected, and only branches that the SimPEG that was under the SimPEG repository could access the necessary credentials to download the files. So they just weren't getting downloaded for pull requests that were originating from outside the SimPEG organization repo. So I just switched around to make it publicly. So now they should not fail when other people do PRs on us, which is nice. I'm not sure if you guys have noticed, but I've been trying to at least follow that practice myself as far as originating pull requests. So I fork SimPEG to my repository and then branch it off from there, and then do a pull request onto the SimPEG master from my own version on here, from my own branch on my own repo. It works out pretty well, and you don't really have any issues as far as so let's say somebody issues a pull request from their personal account. If they do a pull request onto SimPEG, by default, it allows you to modify. It allows us to modify it as well, so we can just go and push to their branch without having to like copy it or anything. It all works out really, but I've been trying to follow that just to have reducing and testing. It seems to work pretty well now. We've got it.
So
Also,
Joe, it's like a three-step process. Like, so if you fork, and like I have something that I had a hard time. You cannot directly make a pull request to a master branch. So
yeah, you can.
Oh, I see.
Yeah.
So you can do that.
Yep. So if you can fork it. I try to keep my own master branch on my personal up to date with the SimPEG master. So the process is, but you don't necessarily have to do that. You just have to fork it to your own repository, and then you can literally branch off from the SimPEG master and then push it to your own copy of the repository. And then you would have a branch on your repository that you can merge into the SimPEG master directly.
Okay.
Yeah, seems to work out pretty well. What else? Oh, I've been working on getting everything ready for the EOAS 350 course. As part of that, I've gotten all of the GeoSci labs notebooks repository, the GeoSci lab notebooks updated for the new simulation branch, as well as a few little operations to make them run a little smoother, like caching some of the things that don't need to be rerun if all you're doing is like, oh, I want to look at the electric field, now I want to look at the, you know, the currents or the potential. Like, there's no need to rerun the entire simulation. So it just makes it a little bit more responsive like that. Yeah, and then I've also updated all the GPG labs to work off the simulation branch as well. It didn't require too many changes, but just a few little things that were getting imported for no reason into the notebooks, and I wasn't sure why.
For the labs, did you try out that like NB librarian approach where you just pull stuff from
as far as having like the notebooks actually like linked, I haven't done that yet. I mean, I know I've done that in my own repositories before to have like, oh, this folder is literally a link to the folder on a different repository or something.
So I think,
if that's what you're thinking.
What I did, and I can show you this afterwards, but I created a little repo called NB Librarian that basically all you do is maintain a list of notebooks and the repo where they originated. So sort of treating GeoSci labs as basically like, this is the warehouse of notebooks. And then that should always
GPG Labs has these notebooks.
Yeah, GPG Labs describes a subset of them, but it should be identical to what's in GeoSci Labs so that we don't have more than one copy of them.
Yeah, no, that's good. I'd like to get with that. Yeah. Like I said, there's also ways that you can like literally have hooks to other repositories within one repository. So like if you look at I think SciPy does it with one of the documentation things. There's like a hook there. It's neat. It just links to other repository. If you download that repository, you get the stuff from the other repository too.
Oh, that's cool.
So, but that would give you probably everything from there.
Oh, okay, right. Yeah, we want just a subset.
Yeah. Other than that, I got my truck back, so yeah, I'll be coming up. Can't really get anybody to help me load it until the weekend, so I'm going to be driving up Monday morning, making the trip. Yeah.
So Joe, are you teaching 350 this year?
No, Michael Bostock is.
Oh, okay. Okay.
I had just met him for the first time over Zoom like a week ago or so. But beforehand, I'm just kind of helping out to get everything up and running for them. They want to get it up on their cluster, have a Jupyter Hub hosted. So
Nice.
for the students to just log into that so the environment's all ready to go for them.
Got it. Yeah. CZ.
I think they wanted a Docker Hub, like a Jupyter notebook from a Docker Hub, but I'm not quite. I think the easiest thing would be, I mean, looking around, reading like, Lindsay, have you ever used the Kubernetes to launch Jupyter Hubs at all? Or is anyone?
I did.
Getting them up on a cluster.
I went through the Zero to Jupyter Hub guide, and so I have launched a Jupyter Hub on Kubernetes or on Google.
Yeah.
But I haven't really ever like maintained one. Are they not going to use the syzygy one? Or are they launching a custom one? I think we lost your audio.
I think they are, but I'm curious if there'll be an easy way to get. Okay.
Oh no, I think you're right. Yeah, sorry.
So they are using they're planning on using syzygy, I believe. I'm just curious if there'll be a way to use the Kubernetes to get up on Syzygy, if that would be easier.
If
I
you
don't
have
know.
questions on that, Ian Allison is a good person to connect with. He's the one who like really actually runs the hub at UBC.
Okay.
He's at PIMS. I can get you his email if you.
Yeah, that sounds good. And then during the semester, I'm going to be helping out, make sure things keep running during the course. And if they have any problems, I'll be on top of that. Just a little bit of extra stuff to do, and hopefully a little experience helping them. And I probably have a little bit more exploration geophysics than the other TAs that they have helping. So that'll be hopefully a good thing. I hope they can take advantage of that. Other than that, I don't think I have anything else. Oh, the volume average stuff, Dom tested that out. Looking at it, I do think it's worth it to put in a special hook for when when a tensor and an octree share the same base mesh, or if two octrees share the same base mesh, because there is a much faster way to do it in those cases. But what I did does work in general, so that's good to test. It's good to know.
Yeah, and I can, I can just keep relying on what's in the mapping for now, because it's like 10 times time, 10x is kind of it's not negligible for large meshes, and then once you have it, we can just swap over. But basically, they're doing the same operation, so that's a good thing.
Yeah. It works for arbitrary stuff right now. So
I know. As
now we can do the special cases.
Exactly. Yeah.
So that's 10 times slower, though? Is that what you meant?
The new implementation, yes, because it's more general, right? So I'm sure, Joe, you're doing some extra special cases, right, to be able to, I guess, a very general approach rather than what's in the tile map is always assuming that the cells are nested, so you can shortcut basically a lot of operations. I'm sure that way.
Oh yeah. And those same, it should work as long, we can do a lot of shortcuts if, like I said, if the octrees and tensors share the same base, then there's a lot of shortcuts. You don't have to do, what takes the most time is just searching. But that won't take nearly as much time if we're just looking at cell centers and finding either thing. Because what it does right now is it builds up, when it's doing octree stuff, it builds up a C++ vector keeping track of the indices that each rectangle overlaps with another rectangle. So if it overlaps with multiple, you can't know how many ahead of time it's going to overlap with. So that's what really slows it down, is that variable allocation.
Whereas the tile map, because I know it's nested, I can use Joe's in-cell octree call, which always returns only the cells that are inside. So then I don't have to search, right? I know exactly which cells are inside and just do a calculation, vectorial, basically.
You can figure out volumes based off the levels of each cells and everything. Yeah.
That's great. Or Joe, have you tested with actual simulation? So it's great. So you got this averaging algorithm. Then have you tested with some simulation? Let's you generate some coarse mesh, but you got fine mesh that you have fine scale structure. Have you tested some of those kind of things? Because it'll be different depending upon what simulation you would use. You probably need to better use either conductivity or resistivity, or that averaging. You probably need to think about a little bit more where which property would you like to average.
When I've used it before on MT and IP and DC before, the volume averaging operation. I was having better luck volume averaging log conductivities instead of conductivities generally. But it seemed to work out pretty well.
Yeah, and I've only tested with the integral equation. So as long as the mass is preserved, and then far field enough, then you don't see the difference, right? But I'm sure with PDE, it's much more critical how you do it. Yeah.
Mm-hmm.
Yep, that's good.
Thanks, Joe. Dom, do you have any updates?
No, well, I did that PR review for Joe, and then I'm still elbow deep in testing the EM1D code for more systems. So I looked at the Helitem, GeoTem, I did more VTem. So yeah, it's just more 1D inversions. I actually managed to get the Harus connectivity model, like their Stitch 1D inversion, so I benchmarked against our code, and the models are pretty similar. So that's really nice. That means we're at least for like straight up like L2, we're really close to what the Danish people are doing. So that's great. It's a good check mark for us.
Yeah, well, I mean, it's pretty simple code, so should match.
Right. That's just always good to check, right? That's and then nothing really SimPEG related after that. So
that's fair. I guess the other thing though, we are on the hook now for SEG, so it looks like we'll have to figure something. Do you know when we need to have those recorded by?
I will check my emails and then forward it to you. I can't remember right now.
No worries.
Yeah. I don't think it's before the end of summer, but I'll double check.
Okay.
So have you figured out like handling the dual moment system in 1D code?
Actually, I just did the high moment, and the survey that I have, the low moment was only like 2 extra early time, so it wouldn't change much. I'm guessing, and the result looked very similar. But yeah, we should talk. Can we actually? Because I saw that you hard coded it, right? Yeah, like a dual moment. System. Could we just treat it as a joint misfit problem?
We could, but at the moment it's not the structure. So yeah, it's hard coded at the moment. So you need to pass both high and low moment.
Yeah, because I kind of diverged from the script that we were working on, and right now I'm kind of. And the way the input files, the way I'm dealing with the inputs and everything, and it's 2 different waveforms. I'm just wondering if we could just not do like a joint problem, and then that way we'd be able to do like both the time and frequency system at the same time. For that kind of idea. Do you think that would work?
Yeah. But I think I generally like it, but like the computation wise, like it only actually like for computing both high and low moment, it only requires a single computation of like frequency response, and then you just need to do a convolution twice because like it's just 2 different waveforms. So yeah, I don't really.
It'll be more expensive if you do it as a joint.
Yeah. So I don't really see kind of why you need to do that. But if you have like you want to handle 2 different systems, sure, you could set up as a joint misfit functions.
Right. Okay. Yeah, that makes sense. I might contact you later. I mean, right now, I don't see why what the low moment really brings extra, since they're overlapping over so many time channels anyway. But I guess the waveform is very different, right, on the low moment.
I think it depends upon the focus, because if you really care about the near surface, like top 100 meter or top 50 meter, it actually brings a lot of information.
Okay.
And potentially you get better resolution at the deeper part because you are getting better resolution near surface.
On top, yeah, right.
So
I will call you when I cross that bridge.
Yep, let me know.
Thanks, Dom. Hey, Devin, so you've joined us.
What's going on?
How's it going? Do you have any updates, things you want to share with the group?
Not really. I mean, I went and tried to fix the import issues that Dieter was having so that he could contribute to the EM1D stuff, but I haven't really touched too much SimPEG recently. It's been all GWB and DC resistivity stuff for GIF tools.
Fair enough.
So have you had a chance to try that out,
Yes.
Dieter?
No, and actually, but just thinking, you remember what was the issue? What it was with the filters, right?
It was just it wasn't importing the supporting functions, and I think there was
that was
an
my
init.
issue, but it's an issue you raised on SimPEG EM1D
Yeah.
to fix something. But yeah, I hope to get it done until next week.
Well, I mean, I guess the first thing is just to see if you can import, like just run the script, right? So it looked like the init.py files were just not good. So I kind of cleaned that up a little bit, and yeah.
Okay.
So I mean, that's at least a first step. So if you can run any of those forward modeling scripts, then that kind of says, okay, you fix the problem. I tried running it in Spider, and I tried running it just from a command line, and I didn't get any issues. But I didn't get any issues before, so.
Okay, I look, because we have to, because the reason I wanted to import it was your issue of unstable solution number 14 SimPEG EM1D. But then there's Soki said, well, that's because radius going to 0, so that doesn't make sense in the first place. So, but I'll have a go anyway.
Yeah, just let me know if there's anything I can do, or if you need me to help you find anything.
Yep.
Hey, Dieter, related to that, in EMPy mode, can I set a arbitrary shape source, like a not just a rectangular source, but if you got, I don't know, like some sort of polygon type like source, can I set that?
Yes and no. Well, you can have an arbitrary rotated dipole, and you can just sum them up.
Okay.
Which it's the same. It would have. No, yeah, it's one of the things on the to-do list to make like a high-level function for that, but it isn't there. So you have to loop over it and sum them up. Right,
but you do have a function, like integral function that can be used to do that. Was that clear, the question? Because you still need to integrate over, right? So if you got a like arbitrary shape source and you compute a bunch of dipole, but still somehow you need to integrate them over.
Yes.
You do have that function.
I have them for, you can have finite length dipoles, right? And I have there the Gaussian quadrature of few points who does that integration. Okay. But yeah, if you want to do it for an arbitrary shaped source, you would have to do it yourself. But you could use the tools implement. I think there's no, I'll have a look if there is an example or not.
Okay.
So I guess the updates I have, I've been playing around, well, again, sort of with the modeling paper with Dieter, and came up with a super hacky higher order interpolation. And so what I ended up doing is basically just grab like a chunk of cells around the receiver and use the sci-fi radial basis function to interpolate. And it actually makes, I mean, if you really do want to drive down errors, it does make a big difference. The other thing that's kind of been interesting to get a sense of is when we really are trying to drive down errors is how sensitive we are to padding. So I'm using the off-tree meshes and then the padding cells to try and get the boundary conditions satisfied without, introducing too many more cells. But you're pretty sensitive to that. So if you really do want to drive down an error, it takes some thought to put that in place. So kind of interesting.
What kind of boundary condition is being used right now on the EM?
It's all the natural boundary conditions. Okay. So yeah, so that's actually something that would be fun to play around with and see see what we can do for conditions.
Which one you call the natural boundary conditions?
So for go ahead, sorry.
No, go ahead.
So for the EB formulation, it depends on which formulation you're using.
Yeah.
So EB, it's B cross N is 0, I believe. And then for HJ, it is then the current density.
Yeah.
Yeah. Actually, so maybe that's one thing I can try to is switch formulations and see what kind of difference that makes. The other thing, so AGU abstracts are due next week. So I'm going to put one, I would like to put one in on MT, and sort of in connection with the Jupiter Meets the Earth project. So sort of focusing in on what are kind of interactive visualizations and things like that we can be doing while an inversion's running. But we'd like to, come up with some good MT examples. So anyone who wants to participate in that abstract, like feel free to add your name and adjust the abstract or make suggestions or anything like that. I'm happy to have a big list of co-authors. So feel free to take a look. If there's anyone else who wants to submit an abstract on anything SimPEG related, feel free to just drop an abstract or a sketch of an abstract in this Google Doc and ping people, and we can all kind of jump in and help out. It would be nice to have a few different examples. I know we talked about a bunch for the GWB project. So if anyone else has ideas, go for it. Yeah, then I guess the last thing is following up on Dieter's comment on Slack, and we talked about this briefly last week, with sort of bug fixing sprints and or time to sort of talk about issues or pull requests that like just need a brief conversation. Dieter, do you want to share what you suggested with everyone?
Yeah, well, I just thought, because I sort of accepted last time to find a time slot, and then I thought, well, it's a bit difficult. I actually wanted to make a doodle, and then I got so confused because of the time difference that everything that would fit me is someone early in the morning. I thought that it doesn't make sense that I do it. I just thought, well, I think there are two possibilities. One is very short but intense, where it's more discussion and distribution, and the other one, and probably more regularly, and the other one would be more less frequent but longer and actual hacking. Or I think you said we could even do both combined. I don't know. So I guess we would have to find a time that fits, like say 1 hour or 2 hours for the longer one, or as I said, for the shorter one, just going through, I don't know, starting with the oldest one and going through. We could do it half an hour after the meetings, or I think as soon as it's a routine, we would actually do it, and if it's not, we don't. Yeah.
For me,
I'm definitely up for that.
excellent.
There's a lot of old issues that are either it'll take a good look at going through them and seeing, okay, is this issue relevant anymore? Can we fix it now? But yeah, like the idea of starting at the old ones and going forward.
Yeah, this could even be done after the meeting, and then if people have to drop out, they drop out, and we say maximum half an hour, and then we cut it until next week, or yeah, something like this.
That sounds good. Does that half hour work for most folks on the regular basis? I mean, it doesn't have to be in general.
Yeah, generally.
Okay.
Maybe we could do like a long, if we wanted to, we could do a longer one on maybe like a Friday afternoon while sharing some,
Some beer?
some drinks, hacking and drinking.
Sounds good.
Yeah.
That really sets a timer on how long we can work though. after an hour.
That's it, like, good 2 hours, like,
No, it just sets a timer how long you resolve problems, and then you start to actually creating new problems.
Well, keeps ourselves busy, right? Yeah, okay, that sounds good. When do we want to schedule sort of a first, well, we can maybe, does next week work for everyone for a first slightly longer SimPEG meeting, and we'll just start tackling, well, I guess maybe Joe, that won't work because you might be on the road.
I mean, hopefully I'll be in Vancouver by the time of the SimPEG meeting on Wednesday, but I'll probably just be in my truck sitting somewhere.
That's fair.
I know I can put a hotspot on my truck or on my phone and mess around for a little while, but
Yeah, if you could push it one more week, that would be good for me.
Okay, that sounds good. So in 2 weeks' time, so maybe what we can try for next week is, even if folks just want to take a quick look at the issues, just so that we sort of see what we're up against. And if there's any that you started, 3 years ago and just want to close because they look like we've addressed them or things like that, go for it. Cool. Okay, so we'll do that in 2 weeks, and then do we want to set a date for a first hacking session, or do we want to just figure that out after 2 weeks?
Let's start with the 2-week one first and see what problems we identify at that one, and then we'll know. Okay, well, maybe next weekend or something, like do them every other week, and this week it's on it's a 30-minute after, the next week or 2 weeks later it's the Friday session or something.
That sounds like a plan. Excellent. Okay, any other things that folks would like to bring up before we wrap things up for the day?
That model testing that you and Dieter are doing, when is that you guys finishing that up soon, or is that still kind of ongoing?
Hopefully. Although we had a meeting, when was that, 2 weeks ago, 3 weeks ago? Then I realized the first email I sent a year ago, and I think for having 4 different projects involved, it's not too bad a year's time. So we said end of August we would like to submit it. So, but it's the repo is online now. It's not.
Yeah. Oh yeah, I saw that. Yeah.
So
I asked because if I can get this mumps version built, like the optimal one, I'd maybe like to sneak that in there. It sounds like it's an interesting problem to see, and you guys have so much other comparison to do, or other comparisons to make with. So if I can slip that in there before you guys are done, that'd be nice. That'd be kind of cool.
That would be awesome.
Nice. I'll keep in touch here. See how today goes.
And then you had there was that paper you were thinking of doing, Lindsay, on the MT stuff and reproducing things. And I guess I see the biggest hurdle being getting the raw data into the SimPEG framework. What file format do you want to start with?
This is the model you were thinking of, we were chatting about on Slack?
Yeah.
Let's take a look. So what are the data in right now? Is it
well, I mean, the whole project and all the steps are actually documented. So you could start off with raw EDI files that have been formatted, or there is the data files that are according to the E3DMT version 2 code.
Okay.
And so that's actually kind of nice. It gives you a separate file where you've defined all of the receivers, and then there's a file that actually just gives you an index. Like, it indexes all of the receivers and provides you the associated data with that.
Okay. Send the link just to that page. That would be great, because I think ideally we should actually be able to read both of those things into SimPEG. So both getting a raw EDI file, which I think you did a bunch of work on a while back.
Really? Yeah.
Then it would be nice to be able to read it.
Yeah, I would almost suggest just using the GIF ones, because the raw EDI files has the whole suite of frequencies, right? And we're just going to pick a small amount of those and invert them and recreate the results. So maybe it's actually best to start with the version 2 UBC. But it's all in there, so I can just send that link.
That would be great. Yeah, and for now that's just in an EGU abstract, but hopefully it is actually something that we could turn into into a paper. So
Cool.
thanks, Jeff.
Are you guys still working on GIF tools? What's the status of this?
There was a demand to create a sensitivity weighting function for the DCIP octree code and to implement a line where you could put in separate cell weights that only act on the smallness term. And we're figuring that out because you can't explicitly compute the sensitivities. You have to do some Hutchinson's method. And so we're fiddling around with a way of kind of creating a sensitivity weights model. And we're making some progress, but I'm not satisfied with it yet. And the final test of that will be, we're doing a comprehensive workflow project for Mount Isa. So you did your Mount Isa results. I'm going through and applying all the new stuff and testing all of the tools that we've developed. And then in the end, we're going to have a standard workflow for DCIP inversion. And when we get to the end of that, one thing we talked about, I guess, a month ago was to then validate those results against SimPEG. So we'd have this, we'd have a comprehensive workflow. We'd have new tools where we have sensitivity weighting for the 3D, like the DCIP octree code. And then that could be reproduced with SimPEG. And it seems like there's a big desire to have SimPEG and UBC GIF codes matching and compare their performance and compare the things that we're getting out. And if we can do that, that's pretty, that would be pretty great. So yeah, once we figured out the that sensitivity weights situation, then it's getting thrown in the GUI, and then there'll be a new release, and then hopefully I won't have to develop that again. It will finally be over.
Sweet, thanks, man.
Yep.
A nice comparison to have. So super cool. Anything else? All right. Have a good afternoon. Thanks, everyone.
You as well. Goodbye.
Bye bye.
Yes.